example. All right, welcome back to example 3. And the linearization of the square root of 1 plus x that we did earlier is actually a specific version of a rule. And here's the rule that 1 plus x to the k is approximately equal to 1 plus kx. Now, we did square root, which is a half. We came up with 1 plus 1/2, our value of x. But this is actually true for any power of 1 plus x. So let's look at a couple examples. First off, the cube root of 1 minus x. Well, let's rewrite this as 1 plus x to the power of k. And what we get is we get 1 plus negative x to the 1/3, which means that we can approximate this as 1 minus 1/3 x. Let's try it. The cube root of 0.99. This is 1 plus negative 0.01 to the 1/3, which means that this is approximately 1 minus 1/3 of 0.01. And that is 0.9966666. It doesn't matter. The cube root of 0.99 is actually 0.9966554,934. And as you can see, my error starts here in the 5th decimal. So my error is going to be less than 10 to the negative 4. Let's do another one. 1 over 1 minus x. Notice that the key to this is to write this as 1 plus something to the power of k, which means that I now know that this is approximately 1 plus k, negative 1, times the something, which is negative x. This ends up being 1 plus x. So if I want to find the value of 1 over 0.99, I could rewrite this as 1 over 1 minus 0.01. Well, that's 1 plus negative 0.01 to the negative 1. And this is approximately 1 plus 0.01, which is 1.01. So let's type it in. 1 over 0.99 into our calculators is equal to 1.01010101. And you probably realize that goes on forever. Notice that we're accurate to the 4th decimal place. All right, next example. Square root of 1 plus 5x to the 4th. Notice that they're getting more complicated. This is 1 plus 5x to the 4th to the 1/2. So there's my k, 1/2. And there's my something that I'm adding. So my linear approximation is 1 plus 1/2 of my something. So let's find the square root of 1.0005. Well, this is x equal to 0.1. K, again, is equal to 1/2. And we can approximate this as 1 plus x. 1 plus k times, k times x And so this is approximately 1.05. Oh, wow. Wow, I completely messed that one up. Okay, starting that over again. One plus k times 5x to the fourth, which is actually 1.00025. This is, I did the same thing I was about to warn you against, is making sure that this has to be the something, not just x. And then I went ahead and typed it in because I was looking back and forth between my notes and my screen. So what's the actual square root of 1.0005? Well, typing that into my calculator, I get 1.000249969. And notice it rounded. It's accurate to about there. So we're talking 1, 2, 3, 4, 5, almost 6 decimal places. And you could calculate the error again by taking the absolute value of the difference. All right. I am going to tell you, my class, to go ahead and do exercise 9 in your book. I'm going to stop this video. I do have some more examples of linearization. I don't want to make the videos too long, and I think this one has gone as long as it needs to. Let's quickly recap. Linearization, L of x, is the derivative at a times x minus a plus f of a. That's just a point slope form for a close to some value, or for x close to a. And it looks like I need to run because I've got another class coming in. I will come back with more examples and more recap in the next video.